Hi everyone, my name is Amirul Lukman bin Kaharudin, and today I will review an article entitled Evaluation of Common Indoor Air Pollutant Reduction by a Botanical Indoor Air Biofilter System. This article are being researched by Izdihar Zahira Ibrahim, Wen Tonchong, Sumyani Yusuf, Ching Sangwang, Ziambo Zian, and Wan Khairul Muzammil in 2019. So, let's take a look on this article. Okay, so in this article, the researchers have focused on improving indoor air quality (IAQ). The researchers think that this is crucial due to the concerns about health risks from indoor pollutants, which often originate from outdoor sources like vehicles and industries. Okay, indoor pollutants also come from everyday household items such as air fresheners and products that contain volatile organic compounds (VOC), as well as activities like cooking and burning incense. Many people spend a significant amount of time indoors where they can be exposed to this pollutant, which accumulate in their bodies over time. Despite this, people often prioritize thermal comfort over indoor air quality, assuming that air conditioning and mechanical ventilation system (ACMV) can solve air pollution issues. An alternative being explored is active botanical biofiltration (ABB) systems, which use plants to filter indoor air pollutants effectively. This system not only filter pollutants but also enhance indoor air quality naturally. Commercial examples include systems like the Geography, Breathing Wall, and Nava One, which integrate plants with biofilters to clean indoor air efficiently. So, researchers are developing prototypes like the Botanical Indoor Air Biofilter, and we call it the BIAB system, which aims to improve indoor air quality in smaller space. This system uses kina fiber and an evaporative medium to enhance pollutant removal efficiency for particles matter 2.5, particles matter 10, and volatile organic compounds. In summary, while traditional heating, ventilation, and air conditioning has VAC system focus on comfort, emerging technologies like active botanical biofiltration (ABB) system, the compact BIAB prototypes offer promising solutions to enhance indoor air quality by effectively filtering indoor pollutants. So, this is the design of the BIAB system. Okay, so from this design, the BIAB unit consists of 3 working sections. The first section is a fraction of pot plants with growth media (PGN) at the face. The second one is an evaporative medium inside the unit, and the last one a mechanical ventilation system at the rear side. We can see it on this diagram. So, the size of the unit is 0.05 meter cubic, which is fabricated from polypropylene plastic and contains 9 spherical openings on the face where the plants grow horizontally from the slots. On the front of the unit, there are 9 round openings where plants are placed horizontally. Okay, so from the slots, these slots in the unit allow air to pass through them, as 27.5% of their surface area is open to facilitate airflow. So inside these slots, they use golden photos as the main plant for this air purification system. The growth medium supporting the plant is made of kina fiber. So this part of the unit includes an evaporative medium, which consists of corrugated sheets made from cellulose materials. These sheets cover an area of 0.12 square meters and have a thickness of 50 millimeters. Okay, so how to keep the plants hydrated and healthy? To keep the plants hydrated and healthy, the unit has a water irrigation system, which is the system powered by a submersible mechanical water pump with a power rating of 8 watts. At the back of the unit, there are axial brushless fans, which is these fans operate on direct current with a voltage of 12 volts and consume 1.44 watts of power. They can move air at a maximum rate of 540 cubic meters per hour. The speed of this fan is controlled by a motor speed controller, which is these fans play a crucial role in the unit's operation. Their job is to pull pollute air through the plants and the growth medium. This air then passes through the moistened evaporative bed, and then once the air is clean, it will release back into the surrounding environment. Besides that, researchers also add evaporative media as media pad into the BIAB system due to the effective mechanism for capturing dust particles and neutralizing odors. Cleaner fiber also was introduced in this BIAB system as the growth media biofilter. So this is the illustration of the BIAB system. Okay, now let's take a look at the method and procedure of this experiment. In this study, the researchers used a method where air passes through the BIAB system only once to evaluate how well it filters pollutant. To evaluate the efficiency of the system, 3 experimental conditions were carried out, which is the 1. Experiments conducted on a BIAB system, plant with grow media section and evaporative medium. Number 2 is the experiments on the plants with grow media system only. And the last one, experiments on the evaporative medium in the respective unit only. Okay, so the arrangement of the experimental condition is shown in this figure. From this, the researchers use a clear auxiliary board that fits the size of the BIAB unit for their experiments. Inside this box, they install LED lights on the top center of illumination. One side of the box had an open window that could swing open from the top, allowing them to place the unit inside. On the opposite side, a flexible duct was attached to the middle of the box. This duct was connected to a device that generates air pollutants. So, to ensure natural airflow through the unit and uniform pollutant concentration in the box, the researcher used a fan, specifically an Acer brushless DC fan positioned at the center of the box near the duct. This fan had mixed the air inside the box effectively. After mixing the air was directed to an exhaust tube connected to the open window side of the box, where it was further analyzed for air quality using an indicator tube. The clean air was then extracted from the box using a vacuum pump. So, in this experiment, the experiment was conducted under control condition, with the temperature maintained at 25 plus minus 2 degrees Celsius, relative humidity at 60 plus minus 10%, and light intensity set at 300 lux in the laboratory. Before conducting the test, they checked the consistency of air pollutants concentration inside the test compartment by measuring it when the compartment was empty. To test how well the air mixed inside the compartment without the filter unit affecting it, they used the airflow generated by the compartment boosting fan. So, to measure the concentration of particulate matter and volatile organic compounds in real time, they use a TXI 8530 dust trap aerosol monitor for particulate matter and a BRAMC BR120 SE monitor for volatile organic compounds. Each sampling session lasts 20 minutes to gather data on these parameters. Now we are going to the result and the discussion. In the result, this is the graph and the table of the experiment's result. From the result, the researchers discussed a few things based on how different airflow rates affect the reduction rates of particulate matter 2.5, particulate matter 10, and volatile organic compounds in an experimental setup involving the BIAB system and comparing it with other systems, plant with growth media and evaporative medium. The first thing that being discussed in this experiment is the effect of airflow rates. The experiment tests 3 levels of airflow rates in different conditions, showing that higher airflow rates led to the faster reduction in pollutant concentration, particulate matter 2.5, particulate matter 10, and volatile organic compound. Next is the comparison of system, which is the BIAB system achieved the quickest reduction in pollutant concentration compared to the plant with growth media and evaporative medium system. Despite expectation, the plant with growth media system, which used botanical biofiltration, did not perform as well as the evaporative medium system, likely due to a lower airflow rates caused by the design factor. Okay, the next thing that being discussed in this article is the volatile organic compounds reduction. Volatile organic compounds took longer to reduce compared to particulate matter due to their chemical nature. Effective filtration of volatile organic compounds requires longer water retention times in the filtration substrate. Okay, next, the article also discuss about the airflow directions, which is the direction of airflow within the BIAB system was designed to optimize pollutant removal. It draws pollute air horizontally across plant and growth media through the evaporative medium stage, and then diffuse clean air. This circulation pattern enhances pollutant removal efficiency. The article also made the comparison with other systems. Commercial systems like active botanical biofiltration (ABB) and ALW vary in airflow orientation, influencing their air elimination process. For instance, systems like the Jungle Free, Breathing Wall, and Nava 1 use different airflow direction to disperse filtered air, affecting their efficiency in pollutant removal. Last but not least is about the prototype system. Researchers have developed prototype system like the Dynamic Botanical Air Filtration (DBAF) system, which use a horizontally aligned plant bed to draw in pollute air and clean it before returning it to the indoor environment. Okay, now we are going to the future research of this article. Future research on the BIAB system should focus on several areas, which is the first one is indoor air quality, energy performance, filtration efficiency, system refinement, cooling efficiency, and the last one is thermal comfort. Lastly, as the conclusion of this article, the BIAB system test in this research effectively remove indoor pollutants like particulate matters and volatile organic compounds. It showed removal efficiency of around 54.5% for particulate matter 2.5, 65.42% for particulate matter 10, and 46% for volatile organic compounds. The system, especially with the inclusion of environment modifier, enhance pollutant removal by absorbing dust and using moisture media to filter air. Future studies should focus on improving the system ability to regulate indoor temperature and humidity. This will help validate its effectiveness and optimize its design for better indoor air quality. That's all from me. Thank you.